nice to.
Yeah, it's
Anyway,
not a
that's
problem.
okay. Yeah, it's in your head. I've heard
Yeah.
it. That's all it matters, isn't it? Okay, cool. Right, decorator then. Decorator is about the structural, right? The structural pattern is where do we want the structural pattern? Where the patterns to structure objects in a way they can communicate well, and also to avoid any messy class hierarchies, and to improve the communication and all that, right? So it's all about structuring, how well you're going to structure these objects, yeah, in your project. So the first one we looked at was the decorator. So the decorator was to, again, we saw how a class hierarchy could become messy. And then if you use a decorator pattern, how we can flatten the hierarchy by using composite units. Like, I mean, each individual objects do their own thing, yeah? Single responsibility, right? Giving a class to do a single responsibility. Single responsibility is one of the solid principles, right?
Yeah.
S stands for single responsibility, right? In that solid SOLID. So single responsibility that we achieved from that example we saw with the decorator. And also the main highlight of the decorator pattern is you can dynamically add behaviors into a system without changing a default object. So remember the example we saw, the shopping cart. So we kept the default behavior of the shopping cart, but we dynamically added the logging and the validation behavior on two different objects without changing the blueprint, the template. Yeah. Yeah. So dynamically, that's the word here, dynamically adding behavior using decorator pattern. Yeah. Yeah. And then, right. Okay, let's carry on then. I don't know why Babitra was keep saying she will make it this Saturday and all that, but
Who's that?
Babitra.
Oh, Babitra. Was she the lady? Yeah, that first was in the first meeting.
Yeah. Yes.
Yeah.
Yeah. Yeah.
She's just busy, I suppose, and
maybe. Yeah.
Struggles of life, I suppose.
Yes. Yeah. True. And then Charit also, I don't know. Wilson, yeah, Wilson is. I know Wilson. I mean, he's not very. He's also very busy.
Yeah, I remember you saying he's your friend in the Caribbean.
Yeah, Caribbean. Yes. But
no, sorry, is that Wilson?
Wilson, yes, Wilson. Yeah. Wilson.
Yeah. Okay.
Anyway, we'll carry on then. At least we are recording this, so we can send it to them and they can have a look at it, right?
Okay,
yeah, cool.
Correct.
Right. So today, let's probably do another one, yeah, and then we'll stop there rather than doing two design patterns on a day. I'm prepared, at least to spend time, allocate the time for two design patterns, but maybe one today then, yeah. Let's see how it goes anyway. How much time do we have as well? So the next one today we want to look at is a cool one. Yeah, it's a cool one, man. I can tell you that. Wait, the second one is adapter. Yeah, look at adapter, right? So let's open the thing. Adapter, as the name says, decorator decorating an object dynamically, decorating an object with behavior. Yeah. And then adapter is to make something adapt, like the plugs we use. Yeah. Imagine you somewhere and you don't have a plug which adapts to this sort of socket, right? In US or something. You go
when you go on holiday.
Yeah. We go on holiday, US, yeah. US, they have different sockets, right? But we can't use our plugs there. What do we normally do? We buy an adapter, right?
Yeah.
To
conform. Yeah, just to change the English plug into an American plug.
Exactly. That's what this thing does as well in the system. If you get into a problem, because of I see the software is also something that we are trying to solve the real life problems in code actually. See, but then we can say, okay, where is the actual physical thing? It's all actually running on the computer, right? I mean, it's the software we're building, but we're trying to solve the real life problem as well. So that's why the nature and the software engineering relates to each other. They come together sometimes, not sometimes, most of the times. We're building something for a physical user, right? But he's going to virtually use that software on his phone or device, but it's going to actually solve a physical his how do you say it, his problem in life, like waking up early in the morning, alarm, and then scheduling something, a calendar, You know, see how things, the software is solving someone's everyday life. So that's why the real life problem would correlate with the problems we talk about in the software engineering. You know, that's why we can see the same example of having an adapter missing, you know, when we go to a hotel or something in the US, can come in the software engineering as well, but it's all virtual though. You see? You see my point? I come in,
Yeah.
how the same problem is coming into coding, you know? So yeah, the same we build something, you know, because we try to create an adapter if you want to represent that in our object, you know, in our system, right? We're building a hotel system, and then we got to create an object, you know, for a socket, you know, because we think like that, right? Yeah. Okay. So let's see the exact same problem that how we will design this in a software engineering, right? If you want to ever design this thing um, in software. So where is this Wi-Fi? Oh no. Yeah. Let's get our board. Okay. Okay. Right. Bear with me because then, I mean, this is something that we're going to solve right together. It's a problem, right? So imagine we're building this system, but we are going to represent the real objects in our code. Yeah. So yeah, let's say, you know, here we have our phone. We're going to just draw things. Yeah. Here we have our phone, and in here we could only use a USB-C cable. Yeah, to connect the phone. Yeah. And then this USB-C cable can only work with a UK plug, right? Let's say the UK plug
Yeah,
pin.
three pins.
3-pin plug, yeah, that's the word.
Yeah.
Yeah. So we need to worry about the plug we're using and what cable it comes with it. Both we need to worry about to connect our phone, right? In UK. This is what we have in UK. Yeah. Right. Now we go to US. We are in a different land. Yeah, US. Right. The problem arises that, you know, they don't have a socket for this UK pin. Sorry, UK 3
pin.
Yeah.
They've only got 2 pins.
Yeah, something like that, right? So here it could only work with a 3-pin. Yeah. Yeah, that's correct. Yeah. So it could only work with 3 pins. Yeah. Here they only have 2 pins. Now the problem, right? So we need an adapter here. We need something to adapt this plug to be connected to that, right? So we need an adapter here immediately. And also, there when you land in US, say that you only have the USB, not the USB-C cable, mini USB cable, you know, like the older versions.
Yeah.
You know, the knobs here, you know, I mean,
Yeah, the old version, yeah.
Yeah, which is like
USB 2.
Yeah, or mini USB or something like that. Yeah. This is the USB-C, the new ones, right?
Yeah.
So you have this cable, but you have your plug, which is the 3-pin plug. Yeah. See the problem? So we need to connect this to go there with an adapter. And also we need another adapter here. Yeah. So these are the adapters we have. Yeah. So we need another adapter here to convert the USB-C to a mini USB or USB 2 to USB-C. Yeah. Then yes, our phone will be able to charge. Yeah. Right. So we need two of these adapters. Let's put this in code, right? So you understand the problem, right? This is the problem we're trying to solve. How do we make this system adapt to it? And we will write everything what we have, and you know, we'll write a bit of function to see, you know, I mean, whether our phone can charge. So the function we're going to write is the phone charging or something. Yeah. We'll see how to make all these connecting to each other with adapters. Yeah. You with me? Okay, cool. Right, let's put this in code then. All right. Oh, upgrade. I always upgrade. See, I'm using this JetBrains tool, Jason. This is a very handy tool. Everyone uses it these days at work as well. You know?
Okay.
You
Toolbox.
can download it. Toolbox, yeah. And it's a very smart tool, you know. It stays always here on the tray, on the notification tray. and it'll check all the development tools are up to date. So see, Android Studio, I saw. Otherwise, you wouldn't know that whether the Android Studio is missing an update or that. I'm
Okay.
open it. See, it notified me that you're missing the update because I did this update at work yesterday, but my personal computer is missing, so it's showing me, and I'm immediately updating. So I'm always staying up to date. And when
Yeah.
it comes to Android development, you need to have all these up to date. Starting with Android Studio. Otherwise, you have seen in my experience that you get into unnecessary problems and waste a lot of days, and then you find out, oh my god, because of my Android Studio is not up to date, and you have to update.
Right.
Yeah, things might don't work. Yeah, because they keep fixing things, right? Yeah, cool. Okay, so let's. Oh, that's updating. Let's open this up then. By the way, can you be able to are you pulling my changes I push into this project every time?
No, I don't use any of the Git commands. Yeah, no, it's only because I usually only download the code from a zip file.
Okay. No, you can
Yeah.
easily do this, right? So what you can do is you will need to first go to Git. Yeah, first go to Git. So this is
Okay.
right. So yeah. So if you come to the project, I've sent the link before, didn't I? So yeah. So go to the GitHub, and then these are my projects. This is our project. So you go here, clone. Yeah, you copy this code, and then
Right.
come to Android Studio or IntelliJ. I always use the terminals. So here you just say git clone and
Okay.
this. Yeah.
Oh, right.
Oh, sorry. What happened there? What happened there? All right. So git clone, and you maybe my I didn't copy the shit. I didn't copy the URL correctly. I think just keep copying. Yeah, copy this properly. Copied, and git clone that. Yeah, and enter, and it'll bring the project into your
Android Studio.
No. It'll download it for you. Yeah, it's going to clone the project into where I'm at the moment directories lesson. So I'm in
Okay.
documents lesson, right? So come out and put it into dev or something like that. So go to directory where you want to clone this project. So first do that, right? And then you go. So once you cloned it, that's what I'm trying to say. So once you clone the project into the directory you want, and then okay, open the project in Android Studio. When you open it, it will say whether you want to open it from a VCS or not. I mean, version control or not. Then you choose that, and you say this is a Git project and blah blah blah, and it will then load it. I mean, you'll open the project in the Android Studio. Once it's open, then you can start pulling always. See this pull? You pull. So that means if there are any changes, it's going to come from the from the repository. See, I am now connected to the Git repository on
Right.
branch. So this project, any changes I make, it will say, oh, do you want to commit this to the repository as well? Because it's connected now. So and the same if I make a change, and if you're at the same time loaded this project through GitHub and everything like I've showed you, then it will say there's a change from someone. Do you want to pull? So you can always make it wouldn't alert you, but you will pull to get the new changes. You see, and see all files are up to date. So there are no changes coming from outside, other than my local version I'm at the moment, right? So that's how we pull and push things at the same time to keep in a centralized place. The code.
Okay. Yeah, I didn't manage. I did. They made me watch some videos on Git.
No,
So yeah, I know the theory behind it, but I never got to use it
no, you
physically.
do it, at least do it once because this is needed though. When you start working, and I mean, you will definitely do this million times. So at least I would say
Okay.
do it once and see. Is it the one we're talking about? So I'll probably do it with you. You share your screen, and then I'll show you step by step, and it's just that. It's just
Okay.
following some series of steps, and then you're syncing. You're syncing your Android Studio to the GitHub project. And that's it. And then you can easily pull. See, I even use a, shortcut, pull, all the times pull. See, so that's how I'm staying up to
And
date.
that is to get, is that just to get the latest
Yes, version
the
changes.
latest version? Okay, the
Correct,
latest
correct,
version.
correct.
Okay.
Yeah. And then if I make a change, say that I add a comment or something, I can push.
All the changes I would make wouldn't affect the repository.
No, locally. But if you want to push like I'm doing now,
Okay,
I've
you're
made a change.
pushing.
See, I put a small comment here showing that's the change going on. See, it's even IDE will show you things nicely. So that's why I don't use
Okay.
Git command line, So
Yeah, I
use the
understand.
IDE, and the studio has all the Git integrated with it. Git commands integrated with it. See, even to show you the difference, it's running a Git command
Yeah.
good. So we don't want to do that by ourselves manually. You see, I'm
Hmm.
seeing the difference, and I'm going to commit the change with a commit message here, to the actual repository.
Gotcha. Yeah.
Yeah. So it's all it's we're syncing. No, right. Cool then. Um, right.
Yeah. Cheers for that. Yeah, I understand.
No problem. Okay. So right. So next is the adapter, right?
Yeah, adaptive pattern.
Yeah. Cool.
And that, what did you say, to make something adaptable to?
Yes. Correct. Exactly like this. This
Yeah.
thing, So we want an adapter here to adapt this
Mm,
plug to be connected to this socket, right?
right.
Same. We need another adapter here to convert this USB to cable
Mini
to
USB.
a
Yeah.
mini USB cable to a USB-C cable,
Yeah.
so that we can connect our phone through these adapters to the socket when we are in US. Yeah.
Hmm.
Yeah. So that's what the adapter means, to adapt a system to be able to work with another. Yeah. Yeah. Right. Um, okay. Sometimes, I mean, people like it. I mean, if you don't put the explanation in the technical words, but if you just tell it in relating to a real life example,
Yeah.
the theory, right? Because you're telling what where would you use the adapter design pattern? That matters the most, you know.
Right.
See, what if see, we can hire someone, who has read lot of books after books, right? And he's telling the definitions, but he doesn't know, what exactly that thing is and where to use it, where to apply it. Because this is all about applying it, right? So if you tell that, I mean, I understand the concept and this is what that is, and this is where I will use it. That's more than it has more weight than, and I mean, telling a textbook definition,
Yeah.
Yeah. You see my point? Yeah.
Okay. Yeah.
Yeah.
Definitely.
Yeah. Right. So, right, adapter. Right. Okay. So let's say, okay, so the function we want to create is, right? Um, charge phone, right?
Hmm.
We want to charge our phone, right? In order to charge our phone, what do we want? We want a USB cable, USB-C cable, right?
Okay. Yeah.
USB-C, which would be a yeah, something like this, USB-C cable or something. Right, we'll create those. Yeah.
Yeah.
I'm not liking this name because it doesn't, it looks a bit odd, Okay.
Okay.
Wait. USB, maybe let's say USB type, um, USB type cable, USB-C. No.
USB Type C.
Yeah, that's better. Yes, I love that word. Yeah, that's good naming actually. Then you can create the other ones you want, with the types ending.
Mm.
Yeah. Cool. USB type C. This is USB-C. Yeah, fine. The name of that. So let's create this as the interface USB type C. And let's identify this. I mean, if we connect this, whether we get the power or not, because that's what any electrical plug or the cable would do, no?
Right.
Yeah. Otherwise, we can't illustrate this in code, isn't it? Yeah. Has power. Let's see. Let's call this has power. Yeah.
Hmm.
Right. Okay. So that's the interface. So let's actually create the cable itself. Yeah. So we will need a class, which is a USB-C. No, we said USB. That's a USB-C. Okay, okay. Sometimes, when you struggle with the C at the moment, right? I want to. The class name will also become the same as the interface. So in that case, people put an I in front of it just to separate. This is the interface. This is the actual
Okay.
session. Yeah, this is also a valid naming convention. People use. So which will implement this thing. And then we need to implement this method, and let's say this return
Boolean.
yeah, of course, Boolean, right? So let's fix our implementation. Let's tell this is always going to say true. That means if I use this cable, power is coming through. Yeah. Yeah. If I make it to false, that means it's not gonna, the cable is not working. Yeah. That's how we identify this. Cool. Right. This is what we need. So USB, we want a plug as well, but then we'll come here. But let's create the main function at the moment, and let's see charge phone. And if I want to call this, I need to pass a USB-C. Yeah. Right. Cool. Oh, no. Okay. Yeah, to charge the phone, we need the cable. Sorry, we need the charger, right? That charger will have the end as a USB-C or USB mini, right? So not this. We want actually the plug, isn't it? The charger plug. Yeah. Remember, because these things are connected together. This is what we have. Yeah. Yeah. This is actually the cable. Yeah. And then there are two parts to it, which is this, the plug itself, and the end, which determine what type of cable is it, right? Cool. So, but to connect the phone, the whole thing we need, right? So, right. So, okay. All right. Okay. So, to charge the phone, yeah. Okay. Let's say, yeah. Let's create the plug. British plug. How do I name this? European plug, right? EU plug.
Oh, yeah. Yeah. Euro plug. Yeah.
Yeah. Okay.
EU plug. Yeah.
Yeah. Okay. So let's create that interface. Yeah. And also this is going to say has power too. Yeah. But because of there are different units, let's say they represent has power in different forms. Yeah. If you use a USB type C, it's going to say true or false. If you use this will tell an integer. Let's say 0 for on. Sorry, 1 for on, 0 for off. Yeah. Let's present it like that, okay? Because otherwise we can use the same
true or false. Yeah.
To differentiate it. So right, so here I need to pass this, yeah. And
the plug.
Yeah. So I'm getting this plug. Let me think. So we're getting a plug, and how do we connect those together? See what I mean?
Do we have to put the wire in there and all that, or not?
Yeah. Oh, no, not.
Differentiate each end of the wire or something. I don't know. Or is that too much?
I'm thinking maybe not. Yeah, you're right. That's a bit too much, because of the wire. We don't care, right? Because of the according to our example here, right? We don't care about the wire. We're not the wires are always going to be the same. Yeah. The main problem comes with the adapters in this case, the end and the start of the cable.
Oh, okay.
Yeah. So those are the units we need to put in code. Yeah. To see whether we are connecting things with the right things. Yeah.
Right.
Yeah. So Yeah.
So what we represent the plug, the
Mhm.
the power plug,
Hmm.
and then we represent the Type C cable.
Yeah.
That's two elements we got there. Is one, so we got the interface, we got the
Yeah.
second interface.
Hmm.
Do we need a third interface, or is it just two interfaces?
Yeah, I'm thinking, maybe we would need another interface. Hold on. Um, mm, yeah. We take the plug. Mm, yeah.
Can I see your diagram again, please?
Yeah. 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 Yes, it's good to look at this too. Hmm.
Yeah, so I was just saying the interfaces were the plug. Um,
Yeah.
so you've got the plug interface, which is the first adapter there,
Mm.
and then the second one. So we've only got two interfaces on there, the two
Yeah.
adapters.
Correct. And also, we are missing a function, right? So the function to connect both of them, like